14.51 is the problem with the collar accelerating up a bar. Before I do it, I'm just going to show a quick unrelated example to make it look a bit less terrifying. This is a fairly non-intimidating problem that we have here, but I'm going to solve for this sort of the effect of the force on its movement in the x direction using the dot product. So you'll notice that if you divide this force up into components, let's say it's 20 degrees, you get the magnitude F cosine of 20, and in the y direction you get F sine of 20. The movement, the direction that we care about, has a unit vector of 1 I hat. It's only moving in the x direction. We don't care about the magnitude. So, in order to find the reaction, the projection as it were, you just take F dot E, calling it B for box. If you do that out, you find that F cosine 20, I'm just going to write this in vector form, F sine of 20 dot 1, 0 is equal to just, well, if you F cosine of 20 times 1 plus F sine of 20 times 0 is just F cosine of 20. Fairly expected result, probably. And just to show you that you do this, you use this principle all the time. It looks intimidating in this problem just because you're doing it in more than, it's not either horizontal or vertical. But the principle of this remains exactly the same. So in problem 14.51, you're given a collar that's around a bar at an angle of 45 degrees that is affected by a force of a rope pulling downwards at 200 newtons. Initially this is at 20 degrees. So if you want to go ahead and free body diagram for that, you have the weight of the collar and then the force of the rope and a normal force here, which we're not going to pay too much attention to. Just note that this is 20 degrees. So, like in the first problem, we're going to put the force of the rope into vector form using I and J components. So I'm just move here. So the force, remember, is 200 newtons. So it'll be 200 times the x component, which is this part, which is sine of 20, I hat, plus 200, then this bit, which is cosine of 20, j hat. And that's the force due to the rope in vector form. Next, you want the force of gravity in vector form, and remember the force of gravity is always negative mg. This is in vector forms, and remember it only goes up and down, so it's going to be j hat. And just plug in the stuff for this, really, negative 8 kilograms times 9.8. Well, that's actually the part that's negative, so you can have a negative mass, but 9.81 meters per second squared. J hat direction gives you 78.5 newtons negative 78.5 newtons. Now we want to take the dot product of the force through the rope and the position, or the unit vector of the bar, rather. Notice unit vector just means if you have a magnitude of 1. So in this case you have an x component that's negative cosine of 45 and a y component that's sine of 45. So it's negative cosine 45, by the way. That's quite important because the bar is tilted in this direction. Think of it as if you're giving directions for someone to draw this bar. If you gave them the directions to do it first with positive, in a positive direction, you'd go da, 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 da. Then you go in a positive y direction, da, 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 da. Right? Goodbye. So if we do this, remember we have 200 sine of 20. It isn't this way again. 200 cosine of 20 dot negative cosine of 45 sine of 45. So what that is 200 sine of 20 times cosine of 45 plus 200 cosine of 20 sine of 45. And if we do that out, you get, oh, excuse me, don't forget the negative on the cosine. Which is over here. Excuse me. Wow. You get 200 sine of 20 times cosine of 45. So negative 48.4 plus 132.9 newtons. That's the force of the rope with respect to the bar. We're going to do exactly the same thing now for gravity. But first, let's just do this sum out. It comes out to 84.5 newtons. Remember, dot product always outputs a scalar. Now let's go on to gravity. Remember, the force of gravity in vector form was negative 78.5 newtons j hat. So in order to find how that is relative to the bar, we're going to take the dot product of this force of gravity times the unit vector of the bar. So we have 0, negative 78.5 dot cosine of 45 sine of 45 equals 0 plus negative 78.5 times sine of 45. And we get, oh, it's not working. Let's write it here. And you get negative 78.5 times sine of 45, negative 55.5 newtons. So we found that the force of the rope with respect to the bar was 84.5 newtons, and the force of gravity with respect to the bar was negative 55.5 newtons. So the net force is just the sum of these, which is 28.99 newtons. To get the acceleration, that's just force over mass. So 28.99 over 8 kilograms, which is the mass of the collar, is 3.62, so 3.63 meters per second squared. And there you are.